Hello students, today we will see the verification of Bragg's law for NaCl crystal. It means that we will verify the Bragg's law for NaCl crystal. तो सबसे पहले पता होना चाहिए कि NaCl crystal दिखता कैसे है. So I have quoted the unit cell of NaCl structure. So this small green sphere means Na plus ions, and this large orange green shaded sphere means Cl minus ions. If we look at the structure possesses Na plus ions at the H centers and at the body center, and Cl minus ions are present at the corner of unit cell. There are 8 corners. Just look at here for 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and there are 6 phases. So NaCl Cl minus ions present at the corners and at the phase center. 1, 2, 3, 4, 5 and last 6. Okay, whereas Na plus ions are present at the 8 centers. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1 Na plus ion is present at the body center of this large cube. Okay, so if I want to calculate the number of Na plus and Cl minus ions in this large cube, so I can calculate that. You know that for FCC this is a face centered cubing because the atoms or the ions are present at the corner as well as the center of the face. So the corner atom contribution, we know that the corner atom contribution is nothing but the 1 by 8. Okay, the corner atom contribution is 1 by 8, and there are 1, 2, 3, 4, 5, 6, 7, 8 NaCl ions, 8 Cl ions present at the corners. Okay, so total contribution would be 8 Cl ions, means total contribution would be 1. So this is 1 Cl. This is for the corner, as well as the Cl ions present at the center of each phase, and there are 6 phases of this large cube. Okay, so phase centered contribution is 1 by 2 and there are 6 Cl ions, so it will be 3 Cl ions. Okay, so 3 plus 1, it means there are 4 Cl ions in this structure. So similarly we will calculate the number of Na plus ions present in this structure. So we know that 1, 2, 3, 4 at the 4 edges at the upper face, 5, 6, 7, 8 at the 4 edges, center edges at the lower face, and 1, 2, 3, 4, that is 4 edges, okay, in the middle face. So there are 4 plus 4 plus 4, 12 Na plus ions which are present at edge center, and the contribution of edge is nothing but 1 by 4, and there are 12 Na plus ions present at the center of edge, so there will be 4, 3, so 3 Na plus ions. Okay, and 1, don't forget 1 Na plus ion which is present at the center of that large cube, that is body centered, so its contribution is nothing but 1 Na. So there are total 4 Na plus ions present in this structure. Okay, so we have calculated there are 4 Cl minus ions present in this structure, and there are 4 Na plus ions present in this structure. So if we add this 4 Na plus plus 4Cl minus, so it will be 4 NaCl. So in this structure, okay, in this face centered cubic NaCl structure, so there are 4 NaCl molecules present in this structure. Okay, so 4 NaCl molecules present in this structure. We have calculated the effective number of Cl ions and effective number of Na ions. So there are effective number of Cl ions is 3Cl minus, and effective number of Na ions, there are 4 Na plus ions, and total 4 NaCl molecules present in this NaCl structure. Now we have to verify the Bragg's law for this NaCl structure, and we know that what is Bragg's law. Bragg's law is nothing but 2d sine theta is equal to n lambda. Okay, so what is d? D is interplanar spacing, theta is glancing angle, n is order of reflection. If n is equal to 1, that is first order, n is equal to 2, second order of reflection, and lambda is the wavelength of X-ray. So we have to verify this law for this structure. So now we will see how we can verify the Bragg's law for this NaCl structure. If we look at this NaCl structure, ये NaCl structure एक बड़े क्यूब का शेप का है, and this big cube is made up of 8 small cubes. Okay, if you look at this region, this is one small cube, this will be second small cube in front side, and there are 2 again small cubes at the back side. Similarly at upper side, 1 2 3 4. So this NaCl structure is made up of 8 elementary cubes, 8 small cubes. Okay, so 8 small cubes. This NaCl structure is made up of 8 small cubes. So 8 small cubes means 4 NaCl molecules. So 1 small cube means what is this? What is then 1 small cube? There are total number of 8 small cubes in this structure. So this NaCl structure is made up of 8 elementary cubes. Okay, and this whole structure consists of 4 NaCl. It means that, again I am quoting, 8 elementary cubes, 8 elementary cubes means 4 NaCl molecules, right? 4 NaCl molecules. It means that therefore 1 elementary cube means 4 by 8 NaCl molecules. 4 by 8 means 1 by 2 means half into NaCl molecules. Means if NaCl structure is made up of 8 elementary cubes, but whole NaCl crystal consists of 4 NaCl molecules. So for 1 elementary cube consists of half NaCl molecules. Okay, now we will calculate the mass of that elementary cube. So mass of elementary cube is nothing but half into molecular weight of NaCl. Okay, now we will find out that half into molecular weight of NaCl means atomic weight of Na, plus atomic weight of Cl. Okay, so it will be half into atomic weight of Cl. So atomic weight of Na is nothing but 23 and atomic weight of Cl is nothing but 35.5. so we'll get half into 23 plus 35.5 is nothing but 58.5, and if we divide this by 2 we'll get this 58.5 is nothing but grams per mole because it is a molecular weight. So grams per mole. Okay, we'll next thereafter, so after some time we'll divide this one by half. Now first of all, just listen that 58.5, that is a molecular weight, is nothing but is grams per mole, means 58.5 gram per mole. And you know that 1 mole means 1 mole, I am writing here 1 mole means Avogadro's number N is nothing but 6.023 into 10 to the power 23 molecules. Okay, 10 to the power 23 molecules, this one 10 to the power 23 molecules. So it means that for a molecular weight of NaCl means 58.5 gram per 6.2023 into 10 to the power 23 molecules. So we will divide it by Avogadro's number. So half into 58.5 divided by 6.023 into 10 to the power 23. Okay, if we divide this and after the calculation we'll get its mass of one elementary cube. Mass of elementary cube will get 4.8563 into 10 to the power minus 26 kg. So after doing this calculation we'll get mass of one elementary cube is nothing but 4.8563 into 10 to the power minus 26 kg. Okay, so for the verification of Bragg's law, first we have to calculate the mass of one elementary cube, and you know that the structure consists of 8 elementary cubes. 8 elementary cubes means 4 NaCl, so 1 elementary cube means half of the NaCl. So half into the molecular weight of NaCl, we will get mass of 1 elementary cube 4.8563 into 10 to the power minus 26 kg. Okay, next we'll calculate the density for that elementary cube, and we know that the density of elementary cube is nothing but mass per unit volume. Okay, so density is nothing but, again I am quoting that density is equal to mass of elementary cube and per unit volume. Mass of elementary cube per unit volume, and we have calculated the mass. What is the value of mass? Value of mass is 4.8563 into 10 to the power minus 26, and volume is nothing but, if the cube is there, just I am quoting that what is how to calculate the volume. If cube is there, this is cube. If suppose this is elementary cube, and how to calculate the volume? If the side of cube is A, all sides are equal, A equal to B equal to C, so cube is, volume of cube is nothing but A cube. So here volume of that elementary cube, suppose in place of D I am quoting D cube. Okay, so how that D comes I will show you. So again I am going back to the slides. Okay, this slide, if suppose, just look at this, just look at my mouse, or this is elementary cube, this one, this, okay, this one is elementary cube. Suppose this one is elementary cube, and I am quoting that the side of cube is nothing but D. If it is D, this is also D, and all the sides I am quoting that D. So the volume of elementary cube, I am supposing, let side is nothing but D. So volume of elementary cube is nothing but D cube. So density will be density, but the standard density for NaCl, but D is equal to standard density of NaCl. Okay, compound, standard density of NaCl compound is nothing but 2.1, and we have to remember the standard density value for NaCl compound. So standard density for NaCl compound is 2.17 into 10 to the power 3 kg per meter cube. So this is the standard value of density for this NaCl compound. So this is the standard value of density. Okay, so here, so we have calculated the value of density, standard value of density. This D is different. Okay, this is density, so I am considering this as capital for avoiding the confusion. So for avoiding the confusion I am quoting density with capital D. So this is the standard value of standard density for NaCl crystal, 2.17 into 10 to the power 3 kg per meter cube. So after substituting the value in this, okay, we'll get 2.17 into 10 to the power 3 is equal to 4.8563 into 10 to the power minus 26, and this D is nothing but side of that elementary cube, D cube. So after calculating, I am bringing this D cube here and this one is here, so D cube will be 4.8563 into 10 to the power minus 26 divided by this one, 2.17 into 10 to the power 3. So after calculating this value, we'll get 2.2379. After calculating this one, okay, we'll get 2.2379 into 10 to the power minus 29, 10 to the power minus 29. Okay, and after taking cube root, we'll get D is nothing but 2.821 into 10 to the power minus 10 meter. So after calculating using the density of NaCl compound, we'll get side of that elementary cube, that is D, is nothing but 2.821 into 10 to the power minus 10 meter. So this is the side of that elementary cube. Again I am going to the back slide. So this is the back slide, and this side, this D. Now just I am quoting this D. The side of unit cell will get the value 2.821 into 10 to the power minus 10 meter. Now look at this D. What is the significance of this D? If I am considering this lower plane, just look at my shaded. I am shading this portion. Okay, I am shading this portion. This is one plane, lower plane of this large cube. This is lower plane of this large cube. Okay, again I am shading the upper plane with this different color. Now this is, just look at this, I am shading this middle plane. Okay, this is the middle plane with a red color. Okay. Again I am shading one plane with other color, suppose this one blue color. Okay, this is the again topmost plane. Okay, if you look at this is lower plane and this is middle plane. So the distance between this middle plane and lower plane would be this much. That is nothing but D, because this is the side of the elementary cube. Similarly, the distance between this middle plane and upper plane, this is nothing but this one. This is also D, side of elementary cube. Means the distance between this middle plane and lower plane, that is nothing but the side of elementary cube. That is nothing but interplanar spacing. Similarly, the distance between this middle plane and upper plane, that is also interplanar spacing, that is D, that is the side of elementary cube. Means side of elementary cube is nothing but the interplanar spacing of that Bragg's law. So we have got the significance of D. D is nothing but the interplanar spacing, and we have got the interplanar spacing D, and we have got the interplanar spacing D is nothing but 2.821 into 10 to the power minus 10 meter. So we have got this interplanar spacing D, 2.821 into 10 to the power minus 10 meter. So with the help of this D, we can easily calculate the wavelength of X-ray, and we can easily verify the Bragg's law, because interplanar spacing is constant for that structure. Okay, now with the help of D, we will verify the Bragg's law. So according to Bragg's law, we know that 2d sin theta is equal to n lambda. 2d sin theta is equal to n lambda. We'll calculate the lambda. Okay, we'll calculate the lambda, and while asking this question, we have given 3 angles, and for those angles we have to verify the Bragg's law. Okay, so given that we have to verify this Bragg law for 3 angles, given that theta 1 is equal to 11.8 degree. Okay, that is for first order, for n equal to 1. Theta 2 23.5 degree, that is for n equal to 2. That is given. Okay, so while asking this question, these conditions are given. Theta 3 is nothing but 36 degree for n equal to 3. So we'll calculate, or we'll verify the Bragg's law for those angles and for those order of reflection. Okay, So first of all, consider for theta 1 equal to 11.8 degree and n equal to 1. So if suppose this is equation number 1, so equation number 1 becomes, and we have d also, d 2 into d 2.821 10 to the power minus 10 meter into sine 11.8 degree is equal to n, means 1 into lambda. So if we calculate this, we will calculate this, we'll get lambda is equal to 1.1532 into 10 to the power minus 10 meter, means 1.1532 angstrom. Okay, angstrom. So we have calculated the wavelength of X-ray for the angle theta 1. Similarly, for theta 2, theta 2 is nothing but 23. That is given condition. All these conditions are given while asking that question. So 23.5 degree. Okay, and n equal to 2. So after putting this one, then equation number 1 becomes this equation number 1 becomes 2 into 2.821 into 10 to the power minus 10 into sine of that angle, sine of 23.5 degree is equal to 2 into lambda. After calculating that, if I bring that 2 into that side, so lambda would be, I will get lambda is nothing but 1.1247 into 10 to the power minus 10 meter, means 1.1247 angstrom. So for theta 1 we'll get 1.1532. For theta 2 we'll get 1.12. That is nothing but approximately 1.1 angstrom. Okay, approximately 1.1 angstrom. Okay, yeah, 1.2. And this is also approximately 1. If I consider this one decimal place, 1.1 angstrom. Similarly, if I calculate for theta 3, if I calculate for theta 3, that is given, theta 3 is given 36 degree and equal to 3. By using same equation number 1, I will get lambda is 1.105 into 10 to the power minus 10 meter, means 1.105 angstrom. Okay, so this is also approximately 1.1 angstrom. So for all these three angles, for theta 1, theta 2, theta 3, means for n equal to 1, n equal to 2 and n equal to 3, for first order, for second order and for third order of reflection, we'll get same wavelength of X-ray, that is 1.1 approx angstrom. It means that for given theta 1 and theta 2, theta 3, for given first and second and third order reflection, we'll get the wavelength of X-ray is similar, 1.1 angstrom. So we can say that Bragg's law is verified. Bragg's law is verified for NaCl structure. So this is the conclusion, and we have given the conditions, or we have given these three angles for NaCl crystal for first and second order, and using this given condition we have proved Bragg's law is verified for NaCl crystal. So I am again revising this. For that, first we have considered the elementary cube and we have calculated the mass of elementary cube. Then with the help of mass of elementary cube, we have calculated the using the density, standard density value, we have calculated the side of your elementary cube, that is nothing but interplanar spacing. And for that interplanar spacing, okay, with the help of given theta 1, theta 2, theta 3, we have calculated the wavelength of X-ray, and it comes to be 1.1 angstrom for all the angles. Hence we can say that Bragg's law is verified for NaCl crystal. So this is the simple verification of Bragg's law for NaCl crystal. Okay, so thank you so much.